So one thing that you may not have seen in college algebra is solving log inequalities. So for example, if we have to solve this inequality, so we must find the interval or intervals where this quantity is less than 1. The idea is to treat this as an equation, but keep in mind that we have an inequality. So how would we combine two logs together? Because remember, when you solve an equation, the idea is to have log of base a of x on one side equals y. So you have to combine the left-hand side into one single log. So we have to use this property that log of a quantity plus log of another quantity is just going to be log of the quantities multiplied. So I just used that. Now I know that if this is the common logarithm, the base is 10. So how can I undo log base 10? What can I do to both sides? Well, I have to exponentiate by base 10. So basically what I'm doing, I'm just raising to the power. This is going to be a power of 10, and this is going to be a power of 10. So this is what I mean by exponentiating both sides. So now log exponential with base 10 and log base 10, they are inverses of each other, so they're going to cancel. So all I have left on the left-hand side is x minus 2 times 9 minus x, and then 10 to the power 1 is just 10. So this has come down to solving just a rational inequalities, which you guys know how to do now. So let's solve this. So I'm going to FOIL this. So I'm going to have 9x minus x squared minus 18 plus 2x less than 10. And I can subtract the 10 from both sides. And I can write it as negative x squared 9x plus 2x is 11x, and then negative 18 plus negative 10 is negative 28, less than or equal to 0. So I can multiply by negative 1, and keep in mind that the inequality sign is going to change, so it's going to be greater than 0. And by negative 1, I'll have x squared minus 11x plus 28. And now I can factor this quadratic. What numbers multiplied together give me 28 and added together give me negative 11, so it's going to be negative 4 and negative 7. Right, negative 4 times negative 7 is 28, and negative 4 plus negative 7 is negative 11. So now I just got to solve this inequality. So remember, we can set up a table. This is x, this is going to be x minus 4, this is going to be x minus 7. And then in the last row, we're going to get our result, x minus 4 times x minus 7. So when x is 4, and then I get x is 7. So when x is 4, the x minus 4 is 0. And when x is 7, x minus 7 is 0. So to the left of 4, this quantity is negative. And to the right of 4, this quantity is positive. To the left of 7, this quantity is negative, and to the right of 7, this quantity is negative. Now, a negative times a negative is going to be a positive. A 0 times a negative is going to give me a 0. A positive times a negative is going to be a negative. A positive times a 0 is going to give me 0. And then a positive times a positive is going to be positive. So where is my quantity positive? What's the answer going to be? Well, it's positive from negative infinity to 4. Right here is positive, and then from 7 to infinity. But we have to take into account that we are working with logs. So we have to take into account the domain of the logs. So we know that I can only have log of a positive argument. So x minus 2 has to be greater than 0. So also take into account the domain. So I have to have that x minus 2 is greater than 0 for this log. and I also have to have that 9 minus x is greater than 0. Nine minus x greater than 0. So from x minus 2 greater than 0, I have to have that x is greater than 2. And from, if I add x to both sides, I'll get that 9 is greater than x. So basically, the answer is going to be where these two intervals intersect with these two intervals. So to get the final answer, what we're going to do is draw the number line and put all our points of interest. So I need 4, 4, 7, and then I need 2, and then I need 9. 2 and 9. So now we have to think. From the domains, we must have that x is greater than 2. So I must have that x is greater than 2. And then x is less than 9. So this is the restriction we get from the domain. X greater than 2 and x less than 9. We're going to have to look only between 2 and 9 for our solution. And then from our inequality in here, we got that x has to be less than 4 and greater than 7. So less than 4 is going to be this, and greater than 7 is going to be that. So the answer, the final answer for this logarithm inequality is going to be 2 to 4 union 7 to 9. So we're looking where the domains and the solution to our inequalities intersect. All right. So this is not anything new per se, because you guys know you should know how to use properties of logs, and then you should know how to solve a polynomial inequality. So this is just came down to solving a polynomial inequality, and then you know how to find the domain of logs. So remember that the log function looks like that. So there's 0 and there is x, right? So x has to be greater than 0. In our case, our input is x minus 2, so x minus 2, whatever I'm taking the log of, has to be greater than 0. Alright, so this is how you solve log inequalities. And then we're also going to, I wanted to go over how to find the inverses of exponential and logarithmic functions. We know how to find inverses. I just wanted to do 2 examples with you guys. So I have this exponential function. So this is an exponential function. What is going to be its inverse? Well, you saw in the review that the inverse of an exponential is going to be a log function, and then the inverse of a log function is going to be an exponential. So how do we find the inverse? If you recall from previous lectures, you set instead of y, so it was step 0, you set y equals to 3 to the 7x, right? We wrote, instead of f of x, we wrote y. And then step 1 was switch x and y. So I'm going to have x instead of y equals 3 to the 7 y. And then step 2, I don't recall if the steps were like that. Solve for y. So there you go. It just came down to solving a exponential equation. Okay, so I need to solve for this exponent. So who's going to allow me to bring the whole exponent down? Well, if I take the log of both sides. So let's take natural log of both sides. So I'm gonna take natural log of both sides. And then this is going to allow me to bring the exponent down in front. So I brought the whole exponent down in front, 7y times ln of 3. Keep in mind I'm solving for y, so I need to divide both sides by whatever y is multiplied of. So 7 ln of 3 to both sides. So there you go. I got that y equals, because the 7 and the ln of 3 goes away, ln of y equals ln of x, 7 ln of 3. So this is my inverse. Step 3, instead of y, write f inverse. F inverse of x is going to be ln of x over 7 ln of 3. So this is how I find the inverse a weighted exponential function. You see that the result is a log function. So this is nothing new. This is finding inverses, so following the steps on how to find the inverse, set the equation equal to y, switch the x and y, solve for y, and that's going to be your inverse. So let's see the other way. When the function is a log, the inverse is going to be an exponential. So step 0 is going to be, instead of f of x, I'm going to write y. Step 1, switch x and y, so instead of y I'm going to have x, and instead of x I'm going to have y. Alright, now solve for x. Step 2 is solve for x, for y. So y is underneath a log, so how can I undo log? Well, I have to exponentiate both sides by the base of the log, so I'm going to do 5 to the power x equals 5 to the power log fifth of y minus 1. So just like we can divide both sides by 5, or we can multiply both sides by 5, we can also exponentiate with base 5 both sides. The reason we do this is because 5 to the power log 5, they're inverses of each other, so they're going to cancel, and all I will have left on the right side is y minus 1. And on the left side, 5 to the x. And since I'm solving for y, I'm going to add 1 to both sides. And this is going to give me that y equals 5x plus 1. And then the last step is, this is the expression of your inverse. This is what y represents now. So f inverse of x is 5 to the x plus 1. So you see, log, its inverse is an exponential. Alright, so these are just a couple of homework problems that you guys have not seen before, so hopefully it will help you with finding inverses and solving log inequalities.